You're once more welcome to grade 9, and our first chapter is some non-metals and their compounds. First things first, we shall be looking at hydrogen. And at the end of this lesson, you should be able to describe the laboratory and industrial preparation of hydrogen. Secondly, we expect you to state some of the properties and uses of hydrogen. And before we round up, you should be able to give a test for this gas. You should be able to tell us how we can test for the gas hydrogen in the lab. Now, looking at hydrogen, the first thing that comes in our mind is that hydrogen is the lightest element known. It is a diatomic gas. A diatomic element or molecule is one with two atoms. Moreover, hydrogen has three isotopes. The first being protium, generally known as hydrogen. Now, this isotope of protium has one proton and one electron. It has no neutron, and that is what makes it unique, a unique isotope for that matter. Now, secondly, the next isotope is deuterium. Deuterium has one proton, one neutron, giving a nuclear number of 2, and as well one electron. And thirdly, we have tritium. Tritium has one proton and 2 neutrons. Of course, we also have one electron. So the nuclear number for what tritium is 3. Now, this tritium is actually radioactive. And remember, we told you last year in grade 8 that a radioisotope is one whose nucleus is unstable, probably due to an increase in amount of neutrons or a very small amount of neutrons. And these isotopes or their nuclei are able to give out excess energy in the form of what? Emitting radiations. And for this tritium, particularly, they emit beta particles. That is one very big tough point. Yes, although we don't need it now. I want us to look at how we can build these 3 isotopes. Let's look at some demonstration here. Now, what we see here are 3 parts: protons, neutrons, and electrons. And like I told you, your hydrogen has just a single proton and of course a single electron. This electron comes to the first shell. I hope you know that. Good. So that is your neutral atom, and of course is hydrogen. The second isotope was deuterium, and we told you deuterium has a neutron as well. So you see, it is still stable. It is still hydrogen. Now the third isotope had 2 neutrons, so we add another 2 neutrons, and we see that it is unstable. So the nucleus is unstable, telling you that tritium is radioactive. So the nucleus is unstable, right? Good. Now, that's said concerning the basics as far as hydrogen is concerned. We now move to the preparation of hydrogen. In front of us, we have the laboratory preparation of hydrogen, and here comes the setup. Now, this is our dilute sulfuric acid. We cannot use the concentrated sulfuric acid because it's a strong oxidizing agent, and at the end of the day, we might have the production of sulfur dioxide and water. So we might not even collect our hydrogen at the end of the experiment. Now we move to our granulated zinc. This is our granulated zinc. We're using granulated zinc and not pure zinc because pure zinc is non-porous. So granulated zinc serves as a forum where you can have an increase in surface area. So this kind of zinc provides an increased surface area for more reaction of what? Your sulfuric acid. And of course, speeding up the reaction, increasing the rate of that reaction. And this is your delivery tube, your tester funnel, your inverted gas jar where hydrogen will be collected. Now, if we run out this experiment, like I told you, so this is your granulated zinc. We have to pour your dilute sulfuric acid through your tester funnel to meet your zinc, and immediately hydrogen gas is given off through your delivery tube to your inverted gas jar. Good. So this is your hydrogen being produced. This gas is actually insoluble in water, so it is collected by the downward displacement of water or over water. So these are some of the aspects you need to note concerning the production of hydrogen in the laboratory. And you have your zinc plus dilute sulfuric acid giving you what? Zinc sulfate and hydrogen. So this is how hydrogen is produced in the lab. We are using zinc and not the group 1 metals like potassium and sodium because they react violently with acids. Secondly, the group 2 metals like calcium and magnesium are very cost effective. And iron, you need to heat it before you use. And even that, they contain impurities, where at the end of the reaction, you can have the production of hydrogen sulphide and sulfur dioxide. Moreover, lead is not used because it forms salts with dilute acids. And of course, you know that copper, mercury, gold, etc. are not preferred since they are found below hydrogen in the activity series. So that is why we use zinc in the preparation of hydrogen in the lab. Now let's move to our slide and see what is there. Looking again at the laboratory preparation of hydrogen manually, like we said, your zinc reacts with dilute acid to give you your zinc sulfate and your hydrogen. You can as well use dilute hydrochloric acid. You can as well use that where we are going to obtain zinc chloride and hydrogen. Now, if we want the gas dry, we need to pass it through calcium chloride or concentrated sulfuric acid. And after drying the gas, it is collected by the upward delivery since it is light. It's lighter than air. From there, we now move to the industrial preparation of hydrogen. Now, hydrogen can be prepared industrially through the following ways. You need to use your natural gas and heat it with steam, and of course in the presence of a nickel catalyst. So you will obtain your hydrogen. Secondly, reacting your water gas and coke, red hot coke, you are still going to obtain your hydrogen. And in the process of cracking hydrocarbons, where you have ethane, for example, using thermal cracking of about a temperature of 700 degrees, so you are also going to obtain your hydrogen. These are some of the ways we can obtain hydrogen industrially. And we can also obtain hydrogen industrially through the process of electrolysis, precisely the electrolysis of brine or concentrated sodium chloride, and even dilute sodium chloride. Good. So learners, that is how hydrogen is prepared industrially as well. Now let's move to the next part of our objective, the test for hydrogen. After preparing our gas and we wish to know if truly the gas prepared is hydrogen, all we need to do is bring this gas closer to a glowing splint, and if a pop sound is produced, then that gas prepared is hydrogen. Before us we have a chemist is holding a metal strip, and on the other hand we have probably an acid, and you know that when an acid reacts with a metal, a gas is produced. So let's see what it's going to do. Okay, so he's dipping the metal inside the acid and he's covering so that the gas produced should not evaporate, and the gas inside is surely hydrogen. Now he will get a glowing splint. This is his glowing splint. Listen to the pop sound. You get a pop sound. Okay, good. So that is how we can test for hydrogen in the lab. We now move to the properties of this gas. The properties of hydrogen can be both physical or chemical. The physical properties of hydrogen include the following. This gas is a very light gas. It is lighter than air, so it is collected by the upward delivery. Secondly, hydrogen is odorless, colorless, and tasteless. It is also neutral to litmus paper. So if you bring a litmus paper closer to this gas, even a moist one, you will find no color change. Moreover, hydrogen is insoluble in water, so it is collected over water or by the downward displacement of water. That is that with the physical properties of hydrogen. Now with the chemical properties of hydrogen tell us how hydrogen reacts with other elements. When we look at the chemical properties, hydrogen will react with the halogens to form the halides. For example, hydrogen reacts with fluorine to give us hydrogen fluoride. And also with chlorine, we have hydrogen chloride. The significance of this reaction is that when your hydrogen chloride dissolves in water, we have a hydrochloric acid. So hydrogen can be used in the production of hydrochloric acid. Secondly, hydrogen reacts with the metals to form the hydride. With potassium, we have potassium hydride. Hydrogen plus sodium, we have sodium hydride, etc. They can also react with some group 6 elements like sulphur to give us hydrogen sulphide. With oxygen, we have water. Another good chemical property of hydrogen is that hydrogen acts as a strong reducing agent, reducing hot metallic oxides to their metals. We shall see that on the uses of hydrogen. So learners, that is how hydrogen portrays physical and chemical properties. Now let us look at some of the uses of this gas. Concerning the uses of hydrogen, we have the following. Hydrogen is used in the production of ammonia, methanol, and hydrochloric acid. For ammonia, hydrogen is required in our Haber process with nitrogen to produce ammonia. And for hydrochloric acid, like we told you before, your hydrogen, when reacting with chlorine, produces a hydrogen chloride gas, and which, when dissolved, we have our hydrochloric acid. Now for methanol, your hydrogen is gotten from the splitting of water. And when this hydrogen combines with carbon dioxide from your flue gas, we have our methanol. You don't need to know this, but I just wanted to show you how hydrogen is used in the production of methanol. Good. Now, secondly, your hydrogen is used in your food processing industries, where they are involved in the conversion of unsaturated vegetable oils to the saturated fats. Good examples, we have our margarine or our butter. Your hydrogen are also used as strong reducing agents, where they reduce hot metallic oxide to their metals. So a good example here, we have iron-free oxide or our hematite reacting with hydrogen to give us our iron, and they are so instrumental in the extraction of iron. They are also used in oxyhydrogen flames, where they are used in cutting metals. And due to its lightness, your hydrogen is so instrumental as rocket fuel and in household heating equipments. Good. Now, before we round up concerning hydrogen, I want us to look at the activity series. The activity series is simply the arrangement of metals based on their reactivity and how they are able to displace hydrogen from its acids. If we look at the activity series, this is where hydrogen is placed. Now, all the metals above hydrogen simply means they are able to displace hydrogen from the acid. And the metals below hydrogen will not displace hydrogen from any acid. Good examples. So if we try to react sodium and hydrochloric acid, the reaction will proceed, giving us sodium chloride and hydrogen, telling us that your sodium has displaced hydrogen from this acid. This is also true for iron. But if we look at copper, copper is found below hydrogen. So reacting copper with your iodic acid, there is no reaction. So you can also try that for gold. What will happen when gold reacts with hydrochloric acid? Learners, that is that concerning hydrogen. And if you have any doubt or any question somewhere you didn't understand, feel free to contact me. I will be more than happy to clear your doubts. And for those of you who understood or enjoyed the topic, please send your 5x5 and stay safe. Bye bye.